Okay, everybody, let's recap the lesson on page 469, and it's lesson 2.1. So it's about exponents. So let's start right here. Anything to the 0 power is always going to be 1, okay? And so when I take a look at example 1 here, I've got a b to the 0, which is 1. So then the answer is just b to the third over 1, which is just b to the third. Okay, 2. Well, the a's cancel a over a, but then x to the fifth is x times x times x times x times x times x over x to the fourth, x times x times x times x. And so cancel x's with x's, cancel x's with x's, cancel, cancel, and you're left with just x. However, it's a faster way to do that, and I think somebody said, well, we just subtract the exponents. So 5 minus 4 is 1, or 4 of these cancel 4 of these, okay? Number 3, we're just going to add exponents with like bases. So a to the 1, a2 makes a3, b2, b3 makes b5. 4, if I add exponents, I get b to the 0 and a to the 0, so that's like 1. They're both 1. 1 times 1 is 1. Just plain old 1, okay? Then we turn the page and we looked at this problem. So we've got Eleanor on social media. She keeps her number of followers keeps tripling every month. So the question is, well, what was her original amount of followers? So we said, well, we could divide by 3 times 3 times 3 times 3 times 3 times 3 times 3, or we can just make it 3 to the 6th, and if we divide 45,198 by 3 to the 6th power, because there's 1, 2, 3, 4, 5, 6 of them, we get 62 friends. That's what she started with. Now the dad does it different. He just adds only 3 every month. So what was his original? Well, he's got 1, 2, 3, 4, 5, 6 threes, which is like 18. So he took this number, divided by 6 threes, and he got 62 friends also, okay? Now what's the difference? Well, first of all, Eleanor is an exponential. Hers is growing exponentially. She starts with 62, and then she triples hers every month. Dad is arithmetic. He starts with 1,128. No, he starts with 62. My bad. He starts with 62, and then adds 3 every time, so that's my arithmetic sequence, okay? We looked at an exponential function where the amazing Aloysius is practicing one of his tricks, and he's going to cut ropes. He's going to cut a rope in half, cuts that in half, cuts that in half. So he takes 10, cuts that in half, cuts that in half, cuts that in half, cuts that in half. So finally the 5th piece is pretty small. Okay, so I graph this, and start with 10 and 5, 3rd rope, 4th rope. And so what happens is it gets closer and closer to 0. Well, in theory, it'll never be 0. So you get this thing called an asymptote. So you get this borderline that it will never reach. It will never reach. So this is called an asymptote. It's a horizontal asymptote. It's a boundary line, invisible boundary line at y equals 0, okay? It will never touch it, never go past it, okay? Because half of a half of half will never equal 0. So then we talk about writing an exponential function, okay? So we know exponential function comes in this form, a times b to the x. We know we start at 10, and we halved it every month. The only thing they want is L of c, so f of x, L of c. The length per cut is 10, 1/2 to the x. It's the only difference. They want L of c as f of x. Then we used it to find the 7th cut. We put 7 here. We used our calculator. We got 0.078125, which is a pretty small cut. Okay. Then we looked at the next page. And the next page, we simply took a look at how do we make an exponential. We're going to back to our y equals ab to the x. Okay, we know we start with 4, because right there, we're taking half of it to the x. On b, we know we started with 8, and we're multiplying by 4. We start with -8, and we're multiplying by 4. On c, we knew we start with 1, and we're multiplying by 4 each time. And on d, we have to be careful. We'll start with -1, and we're tripling each time. We go from 1 to -3 to -9, okay? I can put a 1 right here. That's all I had. So I'll see you tomorrow.